Your program ran fine yesterday. Today Python can't find the package you installed. Here's the real thing. One line of Python, one import, and a wall of red text. No module named requests. But you remember installing requests, so what happened? You're not imagining anything, and none of this is your fault. Welcome along. By the end of this chapter, you'll know exactly what breaks a working Python project, why nothing crashes when the breakage happens, and the shape of the thing that fixes all of it for good. And here's the one that really stings. 2 projects on the same laptop. You install a package for the first project, you never once open the second, and the second project stops working.
How?
Hold that question, because the whole chapter is the answer. To see why one project can break another, we need to look at what's actually sitting on your machine. Picture a shelf. Every piece of code you install arrives as a sealed parcel, and the label on the parcel says 2 things: a name and a version number. The name almost never changes, whereas the number changes constantly, and that number is where all the trouble starts. Every parcel comes from the same place, one enormous public warehouse called PyPI, where anybody can put a parcel on the shelf, and anybody can take one down. So when you type pip install, PyPI is where your machine goes looking. Now watch what pip actually does. I asked for 1 parcel.
For arrived.
Read the lines pip is printing out. Markdown at PY, pigments, DURL. Nobody asked for those 3. And look at the strange little bits of text beside each name, because those are the reasons. Rich can't run without pigments, so pip fetched pigments too. Code that other code needs in order to run at all is called a dependency, and dependency is the single most important word in this whole course. Rich depends on pigments, which means pip must fetch pigments too. Markdown at PY depends on DURL, so DURL arrives as well. That's 2 levels deep from one install, and nobody told you. Look at the order pip chose. So far, everything works, which is exactly why the next part catches people out. Here's the bit nobody mentions. There's only 1 shelf. Not 1 shelf per project, 1 shelf for the entire machine. Your invoice app and your report tool are completely separate pieces of work, written months apart, and both of them reach into that same shelf for the same parcels. And now the 2 projects want different things. Your invoice app was built against Pigments 2.21. Your report tool needs the old 2.0 because the report tool was written back when 2.0 was current. Same parcel, 2 numbers, 1 slot, which means one of those projects is about to lose. So pip does the only thing pip can do and narrates the whole business itself. Attempting uninstall. Found existing installation. Uninstalling. Successfully uninstalled. Pip lifted the parcel your invoice app depends on straight off the shelf, and pip never asked the invoice app what it thought. Then pip prints these 2 lines, one after the other. Pip says error, and names the exact incompatibility pip has just created. And 4 lines later, in the same breath, pip says successfully installed. And then nothing happens. That's the part one want you to sit with. Run the code that's now broken and Rich prints its text perfectly happily, because Rich only reaches for the missing piece on certain code paths. There's no red text, no traceback, no moment of discovery, which is exactly why the damage goes unnoticed. The shelf is simply wrong now, and the shelf stays wrong until some other line of code, on some other day, finally trips over the missing piece. That's why this costs people an entire afternoon. By the time the pain arrives, the command that caused the pain is long forgotten, and that command told you it succeeded. One command would have told you, and almost nobody runs it. Pip check reads the shelf and says, in one plain sentence, which parcel is now wrong for which project. And the loud error from the very beginning? Same shelf, different symptom. The requests parcel is real, requests exists, and you genuinely did install requests. Requests is just sitting on a different shelf from the one your program is standing at. So the loud error and the quiet one share a single cause, the shelf. So, what would actually fix all of this? Before I answer, one quick check that the important word landed. You asked for 1 package, and 4 turned up. What do we call the 3 nobody asked for? Have a think, and pause the video here if you'd like a moment. Ready? They're dependencies, code your code needs in order to run. Here's the answer, and honestly, it's almost embarrassingly simple. Give every project a shelf of its own, and put a wall between the shelves so that nothing crosses over. Your invoice app keeps the new pigments, your report tool keeps the old pigments, and neither project can reach across and touch the other one's shelf. That folder of parcels, belonging to exactly one project, has a name, a virtual environment. So, why does almost nobody keep one? Because of the ritual. You make the folder. You switch the folder on. You carry around in your head which folder you're currently in, because the terminal barely tells you. You switch the folder off when you leave. And the first time you forget any single one of those steps, you're straight back on the shared shelf without knowing. Unless something performs the ritual for you. There's a tool called UV, and removing that ritual is the entire reason UV exists. The folder gets made, used, and forgotten on your behalf every single time, and you never think about any of it. One command instead of 4 steps. We install UV in the next chapter. So, to recap, a package is a parcel with a name and a number, and asking for one parcel quietly brings others along. Your machine has one shelf. Every project reaches into that shelf, and one slot holds exactly one version. And when 2 projects disagree, the last install wins, nothing crashes, and you find out weeks later. Next chapter we install UV, and I'll show you why a tool whose job is installing Python can itself be written in Python.